Long before modern science, long before calculus or computers, there were civilizations solving complex problems with nothing but logic, intuition, and numbers. Imagine building towering pyramids that pierce the sky, predicting the movements of celestial bodies or constructing intricate temples, all without the tools we take for granted today. These ancient cultures accomplished incredible feats using the power of mathematics. They observed patterns in nature, experimented with shapes and quantities, and developed systems of knowledge that would shape the course of human history. Today, we're looking at 5 brilliant mathematical discoveries from the ancient world, and how they changed the course of human progress. You might know trigonometry from school, those sine, cosine, and tangent buttons on your calculator. But what if I told you that a civilization thousands of years ago was already grappling with these concepts without calculators, without even the concept of an angle as we know it? We're talking about the Babylonians. This Mesopotamian civilization flourished around 3,000 years ago, and they left behind a treasure trove of knowledge etched onto clay tablets. One such tablet, known as Plimpton 322, has captivated mathematicians for decades. It contains a table of numbers, meticulously arranged, that represent what we now understand as Pythagorean triple sets of 3 numbers that satisfy the famous Pythagorean theorem, a squared plus b squared equals c squared. But here's the fascinating part. The Babylonians created this table over 1,000 years before Pythagoras was even born. They were using these right-angle relationships in practical applications, like surveying land, constructing buildings, and even tracking the paths of stars. Plimpton 322 provides a glimpse into a sophisticated understanding of triangles and ratios, a testament to the ingenuity of these ancient mathematicians. It's a humbling reminder that groundbreaking discoveries can occur even in the absence of modern tools and techniques. Imagine building a structure as massive and enduring as the Great Pyramid of Giza, a marvel of engineering that has stood for millennia. Now imagine doing it without decimals, without the fractions we use every day. That was the challenge faced by the ancient Egyptians, and they met it with an ingenious system of unit fractions. Instead of writing fractions like 3/4, they expressed everything as sums of fractions with 1 in the numerator, like 1/2 plus 1/4. Think about it. How do you divide a quantity into equal parts using only fractions like 1/2, 1/4, 1/8, and so on? It seems incredibly limiting, yet the Egyptians developed techniques to accurately represent a wide range of values. The Rhind Mathematical Papyrus, a kind of ancient Egyptian textbook dating back to around 1650 BCE, provides a glimpse into their methods. This papyrus contains a table of unit fractions used to divide quantities, along with practical problems and solutions related to surveying, construction, and even baking. This system, while seemingly cumbersome, allowed the Egyptians to achieve remarkable precision in their architectural achievements. The pyramids themselves stand as a testament to the power of their unit fraction system. The fact that these massive structures, built with such precision thousands of years ago, still stand today, is a testament to the brilliance of Egyptian mathematics. Chapter 3. Pythagorean Triples in Ancient India, Geometry of the Sacred. The Pythagorean theorem, the iconic equation that relates the sides of a right-angled triangle, is often attributed to the Greek mathematician Pythagoras. But centuries before Pythagoras, mathematicians in ancient India were already exploring the relationships within these special triangles. The Sulba Sutras, a collection of Vedic texts dating back to around 800 BCE, contain geometric principles used for the precise construction of altars used in religious ceremonies. These altars were more than just platforms. They were considered sacred spaces, and their dimensions were imbued with symbolic meaning. To achieve the desired proportions and shapes, the Sulba Sutras describe what we now know as Pythagorean triples, sets of 3 whole numbers that satisfy the Pythagorean theorem. For example, the texts describe using ropes with lengths of 3, 4, and 5 units to create a perfect right angle, long before Pythagoras. This demonstrates a practical understanding of these numerical relationships, used not just for geometric precision, but also for spiritual significance. The Sulba Sutras offer a glimpse into a culture that seamlessly blended mathematics and spirituality. Their exploration of right-angled triangles and their properties reveals a deep fascination with the underlying order and harmony of the universe. Chapter 4. The golden ratio in Greece, divine proportions. Imagine strolling through the streets of ancient Athens, surrounded by architectural wonders like the Parthenon, its marble columns reaching for the heavens. What is it about these structures that captivates us, that feels both beautiful and perfectly balanced? The ancient Greeks, particularly during the classical period, were fascinated by the concept of beauty and its mathematical representation. They believed that true beauty stemmed from harmony and proportion, and they found a way to express this through a special number known as the golden ratio, often represented by the Greek letter phi. The golden ratio is approximately 1.618, and it emerges when you divide a line into two parts so that the ratio of the longer part to the shorter part is equal to the ratio of the whole line to the longer part. Seems complex? It is, but it results in visually pleasing proportions that appear throughout art, architecture, and even nature itself. The Greeks incorporated the golden ratio into their designs, believing that it reflected a divine balance and pleasing aesthetic. The Parthenon, with its carefully proportioned columns and facade, is a prime example. Even the human body, as depicted in classical Greek sculpture, exhibits proportions that align with the golden ratio. This fascination with the golden ratio wasn't just about aesthetics, it was about understanding the fundamental principles of beauty and harmony in the universe. Chapter 5: The Invention of Zero from Nothing Everything. We often take the concept of zero for granted. It seems like nothing, literally. But the invention of zero was a revolutionary moment in the history of mathematics, and it happened in ancient India. Before zero, civilization struggled to represent the concept of nothingness. How do you write down that you have no sheep, no coins, no objects at all? The ancient Indians found a way not just to symbolize zero, but to integrate it into a powerful system of mathematics. Around the 6th century CE, Indian mathematicians developed a system of numerals that included zero as a placeholder, allowing them to perform complex calculations with ease. This innovation might seem simple, but it was a monumental leap forward. It paved the way for algebra, calculus, and ultimately, the digital age we live in today. Think about it. Every calculation you do on a computer, every line of code written relies on the concept of zero as a placeholder within the binary system. Without zero, our modern world simply wouldn't exist. The invention of zero is a testament to the power of abstract thinking, of recognizing that even nothing has a value and a purpose. Outro: The enduring legacy of ancient math. From clay tablets to code, these ancient discoveries remind us that progress isn't always about the future. Sometimes it begins in the distant past. The Babylonians, Egyptians, Indians, and Greeks, with their elegant solutions to complex problems, laid the foundation for the mathematical principles we rely on today. Their work serves as a source of inspiration, reminding us that with curiosity, observation, and a bit of ingenuity, we can unlock profound truths about the world around us. These ancient mathematicians, with limited tools and boundless imagination, reshaped our understanding of the universe and left behind a legacy that continues to shape our world. Subscribe to The Curious Sequence and see where curiosity leads. Thank you for watching. Subscribe to The Curious Sequence. Don't forget to hit the subscribe button for more fascinating content.